I welcome you all to this 4-week MOOC course on analog electronic circuits, week 2, third lecture. So we'll see the low frequency analysis of RC coupled amplifier, BJT RC coupled amplifier. So low frequency case, again, three external capacitors are there. One is coupling capacitor at input side, coupling capacitor at output side, emitter bypass capacitor to avoid negative feedback. So this low frequency case is divided into three parts, considering input side input side coupling capacitor, first case, output side coupling capacitor, second case, third case is the emitter bypass capacitor. So case 1 is considered here. CC at output side is neglected and the CE considered as a short circuit. So we have redrawn the circuit with considering these two cases. So see here, only input side coupling capacitor is considered. Emitter bypass capacitor is short circuit. Output capacitor is short circuit. So RL dash is RC parallel with RL. Similar analysis we are doing here. V0. The output dependent current source is flowing through the load resistor opposite in direction. So V0 is equal to minus GM VB dash E RL dash. And V0 from the input circuit. Similar analysis we have done from the low frequency and mid frequency analysis. So current flowing through the input side of the junction. See here the current flowing through the input circuit. This is the source RS, CC, RBB dash, RB dash. So I1 is equal to Vs divided by RS plus RBB dash plus RB dash E plus 1 by j omega CC. And VB dash E is the voltage across the resistor RB dash E. VB dash E is voltage across the RB dash E. So VB dash E is equal to I multiplied by RB dash E. So VB dash E is equal to I1 multiplied by RB dash E. So substituting this I1 equation here, VB dash E is equal to Vs into RB dash E by RS plus HIE plus 1 by j omega Cc. Substituting this equation in the previous equation, that is equation number 12, leads to V0 is equal to minus Gm. In place of VB dash E, we are substituting Vs RB dash E RS plus HIE plus 1 by j omega Cc, and leftover is RL dash. And Vs has taken towards LHS side. V0 by Vs is equal to minus Gm into RB dash is HFE. So minus HFE RL dash. And from the denominator part, RS plus HIE is taken common and written on the numerator part. So finally, minus HFE RL dash divided by RS plus HIE is the numerator. So RS plus HIE taken common here 1 by j omega Cc. There is no RS plus HIE. So we are written here numerator and denominator RS plus HIE. And the numerator part is mid frequency voltage gain. So AV low frequency is equal to AV mid frequency divided by 1 plus j omega. In place of omega, we substitute 2 pi f. 2 pi f into Cc into RS plus HIE. Comparing with again the series of high pass filter equations. So you get AV LF is equal to AV MF by 1 minus J F11 by F. So F11 except F remaining components is J and F remaining component is 1 by 2 pi Cc into RS plus HIE. So F11 is 1 by 2 pi Cc into RS plus HIE. Now this is the first case. This is the first case. Case 2. Input side and output side CC neglected. Consider emitter bypass capacitor. Considering only emitter bypass capacitor is a case 2. So we have redrawn this circuit. Output side coupling capacitor is neglected. Input side coupling capacitor is neglected. Only CE has taken. And JD, for the sake of simplicity calculation, we are using JD here. JD is the parallel combination of RE and CE. So ZE is equal to RE parallel 1 by j omega CE. So RE into 1 by j omega CE by RE plus 1 by j omega CE. ZE is equal to a simplification leads to RE by 1 plus j omega RECE. So we'll see here the current flowing through this RECE parallel combination is current from input and this dependent current source. We'll see that in the next slide. So at the input side of the junction, we'll apply KVL. Vs is equal to, we are applying KVL towards input side. The current flowing through this circuit is I1. Current from this port is GMVB dash E. So the current flowing through this parallel combination is I1 plus GMVB dash E. So same thing written here. Vs is equal to I1 into Rs plus RBB dash plus RB dash E plus the current flowing through Z1 combination is I1 plus GMVB dash E. And VB dash E is the voltage across the resistor RB dash E. So VB dash E is equal to I1 into RB dash E. From this, I1 is equal to VB dash E by RB dash E. Substituting this in the above equation, Vs is equal to I1 plus VB dash E by RB dash E, as it is equation, Rs plus RBB dash plus RB dash E plus I1 is equal to VB dash E by RB dash E plus GMVB dash E multiplied by Z. Continuation is there, a long discussion here. Simplification is there. So Vs, previous equation, Vs is equal to VB dash E by RB dash E. So the components is Rs plus HIE plus 1 plus GM RB dash E into ZE. GM RB dash E is called HFE. So taken in the next equation. Then VB dash E is equal to simplification of this equation Vs into RB dash E by Rs plus HIE plus 1 plus HFE into ZE. Now we'll going on to the input side. Input side is completed. Now we're going on to the output side of the circuit. Output side is a similar discussion. V naught is equal to minus GM VB dash E into RL dash. So substituting VB dash E equation here, V naught is equal to minus GM RL dash Vs RB dash E divided by Rs plus HIE plus 1 plus HFE into ZE. So we has taken towards LHS side, V naught by Vs is equal to the leftover component minus HFE RL dash by Rs plus HIE 1 plus HFE into ZE. So we have simplified already ZE equation, we are substituting the same here. It is RE by 1 plus J omega CE RE. So mid-frequency voltage gain should be there on the numerator. So we are making common minus HFE RL dash by Rs plus HIE. So we are taking common from denominator part Rs plus HIE. So the leftover component is 1 plus HFE into RE by 1 plus J omega CE RE into Rs plus HIE. This component is the mid-frequency voltage gain. So we are taking here mid-frequency voltage gain. The leftover component is written here. We can do the analysis with considering this one also, but it's a complex analysis. Make it very simplified. So one is neglected here. One is neglected here. RE gets cancelled. RE gets cancelled. Then the leftover component, the remaining component is AVLF is equal to AVMF by 1 plus HFE by J omega CE into Rs plus HIE. Omega will substitute to 2 pi F. So 2 pi F is substituted and comparing it with the standard equation. Comparing it with the standard equation, F12 will becomes 1 plus HFE by 2 pi CE into Rs plus HIE. This is the cutoff frequency corresponding to emitter bypass capacitor. Previously calculated one is coupling, input side coupling capacitor affected cutoff frequency. This is emitter bypass capacitor cutoff frequency. Next one. Considering the last case, considering the low frequency case, the last case is considering output side coupling capacitor and neglecting input side capacitor and emitter bypass capacitor. So redraw the diagram with all the leftover components. And this diagram is taken as a Norton's equivalent, that is a dependent current source parallel with a resistor is replaced with a voltage source in series with the resistor. So this voltage source will become minus GMVB dash E multiplied by RC and in series with a resistor RC. So the voltage source will be minus GMVB dash E into RC. Next. So output side equation. V naught is equal to minus Gm Vb dash RC multiplied by RL divided by RC plus RL plus 1 by j omega Cc. This is the voltage source. This is the voltage source divided by the total resistance. To get the output voltage across the load resistor, current multiplied by load resistor. From the input side analysis, we have done good number of times. Directly we have taken Vb dash is equal to Vs into Rb dash E by Rs plus Hi. Substituting this into this equation, V naught is equal to minus Gm. In place of Vb dash, we are substituting this minus Gm Vs Rb dash E Rc RL divided by Rc Rs plus Hie multiplied by Rc plus RL plus 1 plus j omega Cc. So here Rs plus Hi is kept in the numerator part, and from the denominator part Rc plus RL will be taken as common. Okay, so minus Gm Rb dash E Rc RL. So we have written one more side, one more time. Then we minus HF Gm Rb dash E is minus HFE. Rs plus Hi is taken numerator side, Rs plus Hie. And from the denominator part, we are taking Rc plus RL, Rc plus RL. So the leftover component is here 1 plus 1 by j omega Cc into Rc plus RL. Then this component is written as RL dash, and leftover component, and omega is equal to 2 pi f. Sorry, here f is missing. So the numerator part is mid-frequency voltage gain and the leftover component. So we are comparing it with standard equation. So we have taken, this is a cascade of 3 filters. So F13 by F13 is equal to 1 by 2 pi Cc into Rc plus RL. So finally, we can say here, the above 3 sets of equations are representing a cascade of 3 high-pass filters. Then the overall upper cutoff frequency is always the maximum of those 3 cutoff frequencies. So same thing is represented here. F1 is equal to max of F11, F12, F13. Then by considering last 3 lectures, we are making a note of here is that AV is equal to AVMF divided by first 2 are low pass filters, second 3 are high pass filters. First low pass filter corresponding to input side internal capacitor. F22 is output side internal capacitor. F11 is corresponding to input side coupling capacitor. F12 will be the emitter bypass capacitor. F13 will be the output side coupling capacitor. So overall, with concluding all these 3 lectures into a single diagram, these 2 are low pass filters, these 3 are high pass filters because of internal and external capacitors. So that's all for this session. We'll continue the remaining things in the next class. Thank you.